Hello everyone, let's go ahead and take a look at the line of best fit and the least squares regression line. Now when we talked about correlation, again we talked about how to quantify it using the R coefficient, and then we can consistently describe the relationship between two variables using direction and strength. Now what we also want to be able to do is actually be able to determine the line that actually best represents or best fits the data set that we have. Now, qualitatively, what we're going to have to include is we're going to have to include this particular coordinate. In other words, here's the average of all the x values, here's the average of all the y values. If we go ahead and find those two values, then we want to go ahead and make sure that whatever our best guess is, it includes this particular point. Now, that, of course, is never going to be mathematically precise nor accurate. And so what we want to do is we want to actually rigorously and quantitatively determine what that line of best fit actually looks like in terms of an equation. And that process is going through a linear regression and finding the least squares regression line. Now, we'll go ahead and take a look at how to do that. That's going to be it's going to be performed much easier using our graphic display calculator, and so we'll go ahead and take a look at how to do that in class. But for right now, what we want to do is we want to take a look at how difficult it is to determine the least squares regression line based upon our best guess. Okay, so let's go ahead and take a look at this. So, let's go ahead and take that off. I'm going to use a different data set here. Let's try this one. Okay, now if we go ahead and take a look at this data set, it definitely has an R value that is going to be positive. It looks like it's going to be maybe moderate, could be a weak, okay, could be a weak to a moderate strength of positive correlation. But again, let's go ahead and just determine for ourselves what we think would be the line of best fit. Now again, we just have to guess. Now of course, if we actually could go ahead and determine what x bar, y bar is, then of course we would have at least one point that we know we would need to include. But for all intents and purposes, let's just say, could it be this? It might be not necessarily that. I don't think this either. But anywhere within this range here, it's anybody's guess, really. So let's just do that. This would be my best guess. Now, of course, if we wanted to go ahead and find the actual best fit using that linear regression method, this is what the line would be. Now, just to go ahead and give you an idea, that's not very close at all. And my best guess is far from the best fit. So notice that it's going to be much more difficult to actually determine what that is just by trying to guess. So again, what we'll use is we use our graphic display calculator to go ahead and calculate the equation of that line for us. So again, just to go ahead and recap what we're trying to do at this point. Again, we went ahead and described correlation. Now we want to actually go ahead and mathematically come up with a line which is going to be the best fit line for the data set so that it can then help us later on with what we want to do, which is interpolate and extrapolate. Okay, so we'll go ahead and again take a look at how to calculate this line of best fit using our linear regression tool on our graphic display calculator. But again, I go ahead and encourage you to play with this particular demonstration to see exactly how difficult it is to best guess the line of best fit. See you then. Bye.